This is problem 20 in chapter 7, where a toy car is whacked by a spring gun and is given an initial velocity of 2 meters per second. It rolls along the track and goes up to a height of 0.18 meters. And it's still going, it's not stopped, and so the question is, what is the final velocity of the car? The car has a mass of 0.1 kilograms. So what we're going to do is we're going to keep track of energy by our tried and true method here. It takes some time to write this all out, but at least if I do it, I know I'll take into account each and every kind of energy for these problems. So this says the initial kinetic and potential energy, that's the mechanical energy initially, plus the work due to friction, which is not in this problem, as well as the external work, which also is not in this problem, equals the final mechanical energy, both kinetic and potential. Initially, the car is hit and it has a 2 meters per second velocity. So it has kinetic energy. It's at our reference level, so we're going to say the potential energy is 0. There's no friction and there's no external forces acting on it. Our interval for this problem starts after the spring hits the car and gives it 2 meters per second of velocity. So there's no spring acting on it anymore. The car does have some residual velocity, final velocity, so it has some kinetic energy, and it also has some potential energy due to its location, its height above the track. So what we're saying here is the initial kinetic energy is converted to some potential energy because it's going up above the ground level, and it still has some kinetic energy as well. So what I need to do is then solve each of these three terms. So the initial KE equals 1/2 mv0 squared equals 1/2 times the mass, which is 0.1 kilograms, times 2 meters per second squared. That turns out to equal 0.2 joules of energy. My final potential energy, PEF, equals mgh, the mass of the car times the gravitational constant times the height, 0.1 kg times 9.8 meters per second squared times a height of 0.18 meters. And that equals 0.1764 joules. That's a 6. So 0.1764 joules. So if I look at this, 0.2 joules equals 1/2 mvf squared plus 0.1764 joules. Okay, I know my mass and everything, so VF equals, let's see, 2 times 0.2 joules minus 0.1764 joules all over the mass and we need to take the square root of that, and that's equal to 0.687 meters per second. So just to refresh our memory what we're doing here, we wanted to find the final velocity of the car as it's going up the hill at a height of 0.18 meters.